Hi, in this video, I'm going to talk broadly about what Git is and sort of the underlying ideas of how it works. We're not going to get into the command line interface or graphical user interfaces or actually using Git. We're just going to talk generally about what Git is. And I'm going to introduce it as a case study, just to motivate why we might want to use Git, especially for code. So if I email a colleague with a subject, the code isn't working, I say, dear colleague, because that's their name, my code is not doing what I expect it to. Could you help? Thanks, Devin. And in this situation, I have attached the code to the file and attached the code to the email and sent them that email. They say they fixed it, they attached it, they sent it back to me. Regards, again, their name is colleague. And so I get it. I delete the file I had before, replace it with the one they just sent me and say, thanks, it worked. What changed? I deleted my old file, so I don't have that anymore, or I now have two different versions of the same file. But I can't just read line by line what is the difference, so I ask my colleague what changed. And the colleague just responds very helpfully, I changed the way you iterate over the list. And I say, which list? There are a lot of for loops in my code, it's long code. I want to know exactly what happened. And on line 241, this is a very helpful colleague. I deleted the file, so I don't know what I had before. And I don't want to make the same mistake again. I want to learn. I want to grow my coding. And they say the line used to be for I in 1, 2, 3, 4, 5, which is bad because if we're iterating over something, Python is 0 index. We want to start at 0. Range will automatically do that for us. So I changed it from that to that, and then they sign it as colleague. And then now I see what happened, what changed my code, and everything works well. All of the information I wanted, I had to pry for, or if my colleague were super helpful, they might have given it to me the way I wanted it, but that's not the most common situation. So a better tool is what's called centralized version control. So on my computer, I have this code. And this is the code with that list in it, that for I in 1, 2, 3, 4, 5. I iterate over a list that way, and that's bad. I can't figure out why it's not working. So what I do is I send it to a remote repository that other people might have access to. I can choose who has access to it. I can make that choice. It doesn't have to be open to the public, but it's something that other people can access. And so my colleague, I give my colleague access to it. They go to it. They pull that code to their own computer. They make this little change it for range in mylist.size. And then they put it back in that place where I put it to begin with. And they also say, use the correct iterator. Line 241 changed from for I in 1, 2, 3, 4, 5 to for I in range mylist.size. And what's interesting about the way Git works is that this is all of the information that the remote repository gets. It doesn't get a new version of that file that it replaces. It just sees this, oh, I changed line 241 from this to that. And that just changes that line. It's especially good if you have very large files, very large code files. You don't want to be uploading and downloading every single file every single time. You just need to know what changed. That's all you need to know is exactly what changed. This is called a diff, short for difference, but it'll be diff everywhere we see it from now on. And then when I pull these changes into my own computer, I see this message that they sent, use correct iterator. Oh, that's why my code wasn't working because I was using the incorrect iterator. It changes that line in the code that I have on my computer. This diff is recorded for all of the history of this project. I can always go back and see that this is something that changed in it. I can go all the way back to my original file based on these diffs without having to have a different copy of my file for everything that changed every time I wanted to collaborate. If I change a different part of the file, so if I change line 239 to be just a regular array instead of a numpy array, this diff doesn't care. It'll just change that line in my code because that's the only line that changed. It'll leave the rest of my code fine. I don't have to delete a file, replace it with a new one, and then figure out I changed this in the old file, so I have to go back to this file and change it again. It's all just there. So when I downloaded my computer, I see who changed the file. So that's something that's there. Also, when they change the file, a human written message about the change. It's like OneDrive, except it nags you to explain yourself all the time. With OneDrive, it automatically synchronizes all of your work and then you pull it if you're sharing a folder with somebody, it just automatically changes everything on you and you don't necessarily know what changed. This, you have to label everything you change. And then when somebody looks back at the history, they can see a human written message about what changed. And it also shows the exact changes in the code. So Git really only works well for plain text files, anything you can open in a text editor, which is all code files, markdown documents, and a lot of different file types, CSV files if those work, but not things like Word documents or XLSX files. Also, if they're not saved like CSVs, they're saved as a binary. PDF files don't work so well like this. Audio and video obviously would not work. You can't say I changed this wavelength from this to that. It doesn't. No. Anyway, so the benefits of this sort of version control is that every single change gets a description. You always see exactly what changed and why, and somebody describes it to you rather than just looking through the code and seeing all the changes. This is especially useful if there are a lot of changes. Everything in Git is based on the difference between files. So if one line changes, we don't need to replace the file. If two people change one file in two different places, they can just be merged together into the same file. Git knows exactly what to do with those sorts of things. If there's a conflict, it will ask you about it and let you change things. If there's no conflict, it handles all of that itself. Multiple people working on the same file on different parts can easily merge that file right back together. And you can always see what happened in the history of each file. So every file has a history. You see all those diffs, you see all the commit messages, and you know exactly what happened.